Hello friends, today in this video I am going to do a change analysis along with the detailed explanation on the unsupervised classification and the supervised classification. For that I have opened my ARCMAP here. Now here I am going to add my Landsat images of my area. I am going to open my bands in the order. That means I am going to insert band 1, band 2, band 3, band 4, band 5, band 6, band 7, band 8, band 9. You can use band 10 and 11 as well, but you can also leave it. But I am going to add, I am adding all of the band here, and I am using Landsat 8 images here. As after the addition of all these band, I am going to open my image analysis here, and here you can see here my all the bands I have inserted in the ARCMAP, and I am going to composite it. Now you can look at here. I have selected my all bands here. Now I am gonna composite it. Now you can see it here in the processing tab window here. I am going to composite my band, all the 11 bands here, and it gives a one composite band of 11 bands, collective one bands. That's why it is called composite band. Now after this you can remove these bands. Now I am going to close this image analysis tab too. Now what the supervised classification is that in simple one line, unsupervised classification is calculated by the software, and the supervised classification is human guided classification. I will tell you in detail here. Unsupervised classification is where the outcome are based on the software analysis of an image without the user providing sample classes. That means it is software guided, and providing sample classes, the computer uses techniques to determine which pixels are related and group them into classes, and the user can specify which algorithm the software will use in the desired number of output classes, but otherwise doesn't aid in the classification. However, the user must have the knowledge of area being classified when grouping of pixels with common characteristics produced by the computer have to be related to the actual features on the group, such as wetland, forest, agricultural land, vegetation, sandy area, tropical forest, etc. This classification in unsupervised classification, it asks us for us to know about how into how many classes we are going to divide it. But in supervised classification, it is based on the idea that a user can select sample pixel in an image that are representative of specific classes. I have done supervised classification in my previous video. You can see in that video that I have selected a certain sample there and classified it, combined it and classified and give it a name as forest. And I have after that I have selected some another classes that I have selected a sample of water there and give it a name, merge and give it a name as water. So in supervised classification, the image processing software use those training sample is reference for the classification of other pixel in the image. Training sample are also selected based on the knowledge of the user. User decide which training sample are classified as which classes on the basis of their knowledge, and the user also sets the bounds for how many similar other pixels must be grouped them together. These bounds are often based on the spectral characteristics of the training area plus or minus a certain increment of the area. That means often it is based on the training sample classes are selected being based on the brightness or strength of reflection in the specific spectral band. So with this, I am going to start my isocluster unsupervised classification here, but I have to select my area of interest here. So I am going to create my polygon here. I am going to my working location. And I am going to create a shapefile here. I am going to create a polygon shapefile, and I am going to use this coordinate system here. Now it is my shapefile. I am gonna give it name polygon. Now I am gonna start my editor. Now Now this is my area of interest here. Now I am going to save my edit. And stop editing. I will make it hollow. And now I am going to extract these areas from my Landsat image, or I am going to clipping out my area of interest here. input raster, composite band, composite output raster, and you can see it here. Output extent means which area we want to clip out, that means polygon area. And now you have to tick this, and with this you have to click just OK. Now after this I am gonna close this, and this is our area of interest. This is our area of interest. You can look at here. This is area of interest that I have created through the shape file. Now I am gonna do unsupervised classification, that I am going to show you here. Isocluster unsupervised classification here. I am going to run it. As I have anymore, so that I am going to delete it, and I am going to add this extracted area of interest only here. I am going to divide it into 7 classes and run it just OK. Now you can see it here. We have divided our area of interest into 7 different classes, and this is our data of 2016 band, and we are going to do a change analysis here. We have taken a data of 2016 and 2019 Landsat images, and we are gonna do change analysis from this year, and what changes are happened from that year to till now of the certain area. Or we can observe how many area of forest area are converted into the vegetation land or grassland, or other changes happening in the nature. From this video you can learn. So what I am going to say is that in unsupervised classification the user must have the knowledge of these blue color represent what land feature, or this green represent to which land feature, and red represent which land feature. So for that you can use Google Earth. You can use your shape file, this polygon shape file in the Google Earth, and use it. Which land feature does it represent? So I am going to explain it with my Google Earth Pro 2. I am gonna open my area of interest here. You have to give it history shape file. You can open it. Yes, click yes. OK. OK. Now you can go to properties and make this outline only so that we can see our area of interest here. Now you can see here this is the water sources and this is sand area. You can see forest area, thick forest area, and barren land. You can see residential area here. You can see it here. This is the positive or the better way to deal with the unsupervised classification if we don't have the idea which color represent what land feature. So with this I am gonna open again my ARCMAP. Now this is my output here. Now I am going to remove other. Now we have to reclassify it again. First of all, we have to put a certain here criteria first. Criteria 1 represent, you can see it here, which I have shown you in the Google Earth. This criteria 1 represent river or the water source, and this blue zone represent agricultural land. You can assign it according to the Google Earth so that it is accurate. Now these red zone are the residential area, and 4, you can see it here in the Google Earth. This light blue is forest area, and 5, these dark color is assigned for, you can see it here again. This is with the vegetation, and and 6 is assigned for urban areas, and 7 assigned for as it is nearby to the river sources, so I'm going to declare it as a sandy area. You can go for a clarify to with it too. Now with this I'm going to reclassify this output. And keep it here, and you have to put or change the new value to 1 to 1000 in this way. We have to change. I will explain about why I am going to change this value. It helps us to observe the change on our data with the time series later on. Now with this I'm gonna give it here name 2016 as it is a 2016 data. You can see it here. Now I'm gonna run OK. Just look at here now. Now I'm gonna uncheck this. Now I'm gonna add my Landsat 10 image. I'm gonna do similar thing as I have done before with 2016 data. I'm gonna add this. I'm gonna open image analysis. I'm gonna do same as before. You have to composite it now. Now after this I'm gonna delete this all Landsat images, remove it. After this, we have to extract our area of interest from 2019 Landsat image. Output extend polygon, and we have to use input feature for flipping geometry so that uh, we can get our area of interest. Now I'm going to click OK only. You can see it here. We have get our area of interest from Landsat 8 image of 2019. Now you can remove these two. With this, we are gonna do again unsupervised classification for 2019 here, and input band is isocluster, not isocluster, but we have to choose our 2019, and I'm again gonna divide it into 7 classes as before. I'm gonna click OK. Now you can see it here, but is we have done reclassify with the 2016 output, but we don't have to do anything with this 2019 output data. We just have to run a a raster calculator here, and we can get our change here, and I will show you every portion. That means which land feature is converted into what, or which land feature is converted into which other land feature. That means sometimes due to degradation, forest area is converted into the agricultural land, and sometimes urban area is extended, vegetation area is extended, and the area of forest get narrow. Now I'm gonna run with this. I'm gonna run raster calculator. I'm gonna open my ARC toolbox, and I'm gonna dealing it with map algebra. I'm gonna run raster calculator here, and we have to subtract your zone from which you have to observe the change. That means I have to observe the change from 2016 to 19. That means what are the changes that have been going through these 2016 to 19, so I'm gonna subtract 2016. I'm gonna subtract 2019 output from 2016. Now you can see it here. This is 2016 data and this is 2019 data. Now with this I'm gonna just click OK. You can see our output is ready. Now you can open attribute table of your polygon first. And you have to add a field here called area. You have to put it a type. Now this is the area of your I'm gonna keep it in hectare. So this is our area of our polygon. Now I'm gonna show you the output attribute here. You can see we have assigned criteria 1 is 1000 in 2016 area. In 2016 Landsat image, that means this we have assigned 1000, 2000 and 3000, 4000, 5000, 6000 and 7000. As I have mentioned, this 1000 assigned for river, 2000 assigned for agriculture and 3000 assigned for forest area, 4000 assigned for vegetation and 6000 assigned for urban area and 7000 assigned for sandy area. Don't confuse with my criteria here. You can, I have just given an example here dealing with the change analysis. Now you can also add here your area field. You have to just click OK and you are gonna dealing with calculate geometry, but here we are not gonna dealing with this now. First of all we have to unstick this. You have to open attribute table and field calculator, click S, and you have to determine area by your count and your pixel size. So to know your pixel size, you have to go to your raster and right click on it and open properties and go on a source, and you can see here cell size 30 into 30. It is in meters, so I am gonna open my attribute table here, and in area field I am gonna do it field calculator, and again with this I am gonna double click on count, gonna into 30 into 30 divide by 10,000, as I wanted my area in hectare, so I am gonna divide it in by 10,000. With this you can get your area of every changes that occurred through 2016 to 2019. You can see it here. I'm going to make it little bit larger, my attribute table. Now why I am assigned my value is 1000. I will explain you now. Here you can see I have assigned 1000 is my river. So this I have done, I have subtracted 2016 minus 2019 our output data, and this data, this 16 data is subtracted from this. So here we can see 1000 minus 7, that means you can see it here 993. What does it means is that your river area is converted into sandy area by this 993. Data shows that this 2691.54 hectare area is converted land from the river. That means now in a new today in present time, this 2691.54 hectare portion of river is now a sandy area. We can get it. In 2016, this area is a river and a water source, but with the time change it is converted into sandy area, and now we can see it here too. And this 994 means I have converted it here. 994 means we have subtracted 1000 minus 6 means 994. That means our river area is converted into 6 means urban area. That means 1801.62 land is converted into the urban area with the time change of 3 years to the urban areas. And similarly 995 means 5. We have assigned 5 is vegetation. So river area is converted into vegetation land 204 hectare. And 996 means we have assigned 4 is forest area. River area is converted into forest area, and you can see it here. 998 means agricultural land. River area converted into agricultural land too, and you have to understand it here. 1000, this 1000 minus 1, as we can see, 1 also assigned for river source and 1000 also assigned for river source. So 999 means it is unchanged portion. That means it is a river. Now at present situation, this is our river or the water sources area in our this Landsat images. So in this way we can observe the change analysis here and calculate every bit of area which is converted into other portion. Now in this video I am gonna dealing with only this. Now you can observe all this value, and you can observe agricultural land can converted into forest land, agricultural land converted into residential land, agricultural land converted into vegetation land, agricultural land converted into sandy area, and every portion, every criteria must have converted into other portion with the time changes. And you can see it here. I have converted every criteria into 7, so our final output will be of 49 object ID. You can see it here. 7 into 7 every criteria. This forest criteria converted into 1 2 3 4 5 6 7. 1 2 3 4 5 6 7, and this second criteria is also converted into 7 parts, and this also changes into 7 parts, and this fourth criteria is also converted into 7 parts, and 6 also converted into 7 parts, and 7 also converted into 7 parts. Now after this I will show you the changes. Here you have to clear this selected area. Now you can change the color stripe here. I am going to put it this color ramp here and click OK here. It seems little. I am going to change my color here. I am going to use this color. Now this is a bit suitable than before previous use color. Now with this you can see a change here. You can open image. You can see it here. The change from the 2016 data. You can make it little bit narrow so that you can view in more clear way. You can take it here. Now you can this is our 2016 data. I am going to check this, and this is our final output, raster calculator output. Now you can see it here, the change. You have to uncheck this also. Now with this you can see the 2000. This is the 2016 data, and this is our final out. You can see it, the change here. You can see it here. This is the changes. In this way we have calculated area of the changes portion, and we have done the change observation here too. With this I am gonna end this video here. Thank you for watching.